Hello, welcome to Leetcode Biweekly Contest 146. We are solving problem. Second, count paths with the given XOR value. So in this problem, we are given a 2D integer array grid with the size m cross n. You are also given integer k, and our task is to calculate the number of paths you can take from top left 0, 0 to bottom right m minus 1 to n minus 1, satisfying the following conditions: that you can either move to the right or down. Formerly from one cell ij, you can move to I comma j plus 1 or I plus 1 comma j if the target cell exists. Okay, and the XOR of all the numbers on the path must be equal to k, and we need to return the total number of such paths. And since this can be very large, we need to return the answer modulo 10 to power 9 plus 7. Okay, so basically the problem says that we will be given basically a 2D matrix, and we have to starting from the top left, that is 0 comma 0, we need to reach the bottom right, that is m minus 1 to n minus 1. Now whichever path you take, there will be numbers at a particular cells, at every cell, sorry, not particular cells, and the XOR value you take of all the numbers, finally you land up at m minus 1 comma n minus 1. The XOR value should be equal to k. Okay, so they have given the constraints. As in this problem, we will be given a grid of vector and an integer k. Okay, so if we see the constraints, so it says that the length of the grid will be 300, and grid dot r, that is the rows and column, will be 300 into 300. The maximum can be 300 into 300, and if you see, the value of k can range from 0 to 16. Okay, so this is the first case. Now what I did, that forget about initial dp, so I'm just following a recursively, for sake that ignore this wherever I'm using dp. So if I comment this dp stuff out and this dp stuff out and the updation part, first think about the recursive code. This is a normal recursion code. If the constraint could have been low, we could have easily solved it. What we are doing is we are going to recursively, that we are taking I and j. I and j basically represents my particular cell's denotions on which axis it is lying. After that, I have the k value, which is already passed in we are given in the question. Current is the current value of all the XOR's value, or the paths that we have taken, that whatever path we are taking, the total XOR value of all the elements on that part is the current, that is denoted by cur variable. Now we have also grade. Now what I'm here doing is that if I'm starting it from the bottom right corner, that is I'm starting from n minus 1 comma m minus 1, and when I finally reach I equal to 0 and j equal to 0, finally these are base conditions. At that point of time, I will check that cur, which is the current value, that XOR with grid 0 comma 0 is equal to k or not, because when we land up at 0 comma 0, we are not taking into account the grid 0 comma 0's XOR into it. So that is why taking the XOR, and if it is matches with k, we will return 1. Otherwise, in all the rest cases, it will be 0. How? That if anyhow I'm not reaching uh, 0 comma 0, or I'm reaching 0 or minus 1 or minus 2, so for that case I have seek that if either my I get less than 0 or j gets less than 0, simply return 0 for that case. Okay, for as of now I am ignoring this dp part and this part. Now what I would be doing, I will be taking this into account, that whenever we are at I comma j, what I can do is, since the problem says I can go down and right hand side, so if we are starting from bottom, I can go to one cell above and one cell to the left. So that is what I'm doing. I'm going one cell above, taking the current value with the current grid value that will be updated, plus I'm taking j minus 1, that is going to the left. Okay, and updating with the current with the grid. So same, all the stuff remain the same, just the difference will be I and j. How I and j will vary based upon whether I'm moving up or I'm moving going left. All that sum finally will be returned. Okay, but recursive code won't solve a problem because of the constraint, so I will have to optimize to memoization basically, because I will be storing, because at a particular cell I will be moving a number of times, and that I don't want. If I am going to a cell again and again, why not I store it in some in some of my I basically calculate that answer what would be if I from bottom right to that cell, so that will be stored in a dp vector. So what I've done is I've created dp vector 3d dp. Why so? Now if you see in this recursive code, there are three variables that are changing their states. That is, I is changing, j is changing, and whatever the current value of the parts that we have taken, that is changing. Okay. So for that, three states are changing. That is why we have maintained this 3DDP over here. So this 301 that will be for I and j, that is rows and columns or my grid that is we are given, and for the current value I'm maintaining it in k. So, and that is why I've maintained it of size 70. So what I'm doing is initializing my DP with -1, okay, and checking in this condition. This normally we are converting the recursive code to memories code. So checking that if DP of ij and cur, if it's not equal to -1, simply return DP of ij cur. Otherwise, whatever the value we were returning, we will simply store in DP of ij and cur, so that we won't have to iterate over again. So if we gradually move to tabulation form, we can easily reduce it to 301 into 17 by optimizing the space. But this was the working code, so recursive converting it to memoization, that worked for me. So if you have any query, do comment it out. And if you like the video, hit the like button and do subscribe for more daily content, guys. Thank you.